reaction we're going to consider, which is not reaction number 6, is hydroboration slash oxidation. Okay, hydroboration slash oxidation. So this reaction involves the addition of what? Water to an alkane following the anti-Markovnikov's rule. So what you're going to follow in this reaction is anti-Markovnikov's rule, which involves the addition of water to an alkane, to an unsymmetric alkane following the anti-Markovnikov's rule. So the reagent for this hydroboration is a borohydride dissolved in sodium hydroxide and a hydrogen peroxide, or you can use a diborane dissolved in peroxide. Okay, so this is the reagent to use for that converts the alkane to an alcohol following the anti-Markovnikov's rule. So in this reaction, water is added to an alkane. In this reaction, water is added to an alkane to produce an alcohol. Okay, so the addition of water to this alkane follows an anti-Markovnikov's rule. Example, let's say we have something like CH3, CH double bond, CH2, propane. If you carry out this reaction using this reagent, let's say borohydride with sodium hydroxide and peroxide, so this reaction will initiate the addition of water to this guy following the anti-Markovnikov's rule. So remember what happens when water is added following the anti-Markovnikov's rule. The hydrogen in the water will go to the one that has less hydrogen. That's for anti-Markovnikov. So hydrogen will go to this carbon, okay? Then the OH will go to this carbon. So I'm going to have CH3, CH2, CH2, OH. So this reaction will give rise to a 1 degree alcohol, okay? 1 degree alcohol can also be called a primary alcohol. And this alcohol, the name is propanol, okay? Propanol. So that's the number 7 reaction. So the next reaction is, let's look at the reaction with KMNO4 in aqueous solution. Reaction with KMNO4 in aqueous solution, that is dissolving KMNO4 in water. So this reaction can also be known as Bayer's test, right? Bayer's test. It's a test for unsaturation. This reaction is a test for unsaturation to confirm that there is a double bond or a triple bond. So this reaction will lead to the formation of what we call a glycol. The addition of KMNO4 to the reaction of KMNO4, aqueous KMNO4 with an alkane, will lead to the formation of a diol, or you call it a glycol. So example of such reaction. This reaction, why is it a test for unsaturation? It's a test for unsaturation because the purple color of the KMNO4 disappears or decolorizes when it reacts with an alkane. So it's only unsaturated compounds like alkane that can decolorize the purple color of KMNO4. So, for example, if I have, let's say I have ethane reacting with KMNO4 aqueous, that is KMNO4 in water. So this reaction will lead to the formation of a diol. A diol is attacking 2 OH group to the point of unsaturation. So I'm going to have CH2 OH, CH2 OH. So what I did was simple. I added an OH group to these 2 carbon. So this compound is also called ethan 1,2 diol, or you can call it ethylene glycol. Okay, so this compound, diols or glycols, are formed when you react aqueous solution of KMNO4. So this follows an addition reaction. So we said that this is a classical test for alkanes because the purple color, this solution of alkane decolorizes the purple color of this KMNO4 and turns it what? Colorless, which will give you the product of this reaction. Okay, so these are some of the additional reactions we are going to consider. So the next reaction we are going to look at is not an additional reaction, it's also a reaction of alkane, but it's not an additional reaction. That reaction is called ozonolysis. I believe you have heard about it. Ozonolysis, okay? So ozonolysis, this is a reaction of an alkane with an ozone to form an ozonide, okay? Ozonolysis is a reaction of an alkane with an ozone to form an ozonide as the intermediate. That ozonide is not the final answer, okay? Because the ozonide is just an intermediate. So the ozonide will further react with zinc in water or zinc in sodium carbonate to produce the carbonyl compound, either an aldehyde or a ketone. I repeat myself again. I said in ozonolysis, the alkane reacts with an ozone, O3. The ozone will attack the alkane to form an ozonide, okay? So that ozonide will further react, it's not the final answer, it's an intermediate. That ozonide will further react with zinc in water or zinc in sodium bicarbonate to form a carbonyl compound. The carbonyl compound is likely going to be formed depending on the alkane, is either an aldehyde or a ketone. So let me show you the shortcut of getting this answer without passing through all this long step, okay? If you are given an ozonolysis of an alkane with ozone and zinc in water, let's say for example, I have an alkane, let's say I have CH3, CH double bond, CH3, CH2, sorry. Okay, no, let me just say CH3. Let's use but2N, for example. This is but2N undergoing ozonolysis. Ozonolysis simply means reaction with ozone and also zinc in water. Or sometimes you can use zinc in sodium bicarbonate, right? Like this, okay? So, but let's just use zinc in water. That's the one. We can also use this. So, in this reaction now, what happens in this reaction? This reaction will lead to the formation of an aldehyde or ketone, depending on the what, on the alkane. So, look at the easiest way in getting your answers for ozonolysis. Just look at where the double bond is. Cleave the double bond here, cleave it here, that is breaking from here, and insert 2 oxygen at both sides. So, we are going to have CH3. Remember that this is what I'm talking about. This carbon has a double bond here, okay? So I can put the double bond here, the half of the bond here, and then insert oxygen, then the hydrogen will still remain here, right? So I've done for this. Then for the other one, plus, the same thing happens here, but turn it the other way around. It's going to be CH3, C, insert oxygen here, then put your hydrogen here. So from here, insert oxygen this side, so the ozonolysis of this reaction will produce 2 moles of ethanol, or you can say 2 moles of acetaldehyde. Okay, so this is the ozonolysis of this reaction.